So let's see another problem here, which is again about equating area to find out length. Okay, we have been doing many problems in this pattern. So let's see one more problem. This problem came in the year CAT 2003. So let's understand what is being given here. In a triangle ABC, AB is 6, BC is 8, AC is 10. As soon as I see this, without even reading any of the further problem, I understand that this is a Pythagoras triplet. It's a right angle triangle. Because it's a Pythagoras triplet, which is 3, 4, 5 multiplied by 2, this becomes 6 and then 8 and then 10. Okay, that is the first thing that I understand as soon as I read this. Then a perpendicular is dropped from B, meets side AC at D. Then a circle of radius BD with center B is drawn. If the circle cuts AB and BC at P and Q respectively, then what is AP is to QC. Okay, that we'll understand it better as soon as we draw the diagram. So we know that it's a right angle triangle. Okay, there is no issue in that. So let's start by making a right angle triangle, and let's put the condition which are being given here. So I make a right angle triangle here like this. I understand that out of this AC is the hypotenuse because AC is given to me as 10. So this is 10. Then AB, so let this be AB, this angle is equals to 90 degree. AB is given to me as 6, so I will put AB as 6. And the other side is given to me as 8, so I'll say BC is equals to 8. Okay, that's how I start with the problem. A perpendicular is dropped from the B, meets the side AC at D. So let's draw a perpendicular. Perpendicular is drawn from the B, meets the side AC. This is a perpendicular, so 90 degree. It meets the side AC at D. So the point where they meet is D. Let's change the color. Okay, that's all I have it till now. Now, what else are they putting? A circle of radius PD with center as B is drawn. So now with center as B, I draw a circle which has a radius of BD. So let's draw a circle. And let's put the condition which are being given here. So center as B, I draw a circle with the radius equal to BD. So circle would look something like this. Correct? So let's put the circle in the right position where it will be something like this. Okay, so that is also something that is clear to me. Let's reduce the size. Okay, looks good. Something like this. So what do I understand from this part? As soon as I see this, what do I understand from this part? That I will have to equate area. Okay, I will have to equate area formula to reach on to the answer. But which formula of area will I equate? Okay, that is what you will have to think. So clearly it looks like half into base into height. Now see what is being given and what is being asked. They are asking me what is AP. So it is intersecting AB and BC at the point P and Q. So it is intersecting AB at B. So this point is P, AB at P and BC at Q. This is P and this is Q. That is given to me. What is being asked is what is AP? What is this length? AP. And what is this length? QC. Okay, that is a question that I have. So what do I already know? I know BC. If I come to know what is this, I can find the answer, right? And what is this? This is nothing but the radius of this circle. Okay, understand it better. See, this is a circle. Again, this is nothing but the radius of the circle. That's all you have it here. So this is, as you can say, BD is the radius. BD is equals to PQ is equals to BP. All these three are radius of this circle. So if I know the radius, I know everything, right? I can just subtract the radius from it to get my QC. At the same time, I can subtract the radius from 6 to get to my AP. That's how simple it is. So can I find the radius? Yes. By how? By equating area. How will you do that? Applying two different formula of half into base into height in a same right angle triangle. We had done this before. I told you this will come many times. Okay, so this came again. So half into base into height means half into 8 into 6, which is 8 into 6, 48. Half of that is 24. That is equal to half into base. Here the base here is BD. So apply it in this way, right? Half into base into height is equals to half into base. Base is here 10. Okay, into height, that is equal to BD. So half into 10 into BD. I need to find out BD because that is the radius. Okay, so what happens? Half gets cancelled. 8 into 6, 48. BD is equals to 48 upon 10. BD is equals to 4.8. And that is nothing but the radius of the circle. Okay, because it has a center of B. So it is going like this. This becomes the radius. Okay, I hope you are able to visualize with this. So once I get this, I know that this is equals to 4.8 R. This R is again equal to 4.8. Okay, and then you can reach on to the answer. Okay, before I tell you that, see, if you're not able to understand that this is the radius, you can look at it in one more format. Okay, this is a circle and this is a perpendicular, and this turns out to be a tangent. Okay, so a line from the center to the tangent is always perpendicular to the tangent. So this is already given as a perpendicular, so this becomes a tangent. Okay, automatically this becomes a radius. One more way to look at it, even if you don't think in this way, it's quite visually can be seen that it's a radius. So now just subtract. Okay, 6 minus 4.8 is what? 1.2. That is your AP. 1.2. And 8 minus 4.8 is what? 3.2. That is your QC. Okay, so it turns out to be as 12 by 32. 12 by 32 is 4 3s are 12, 4 8s are 32. 3 is to 8. Option number D is your answer to this question. So again, what I did here? I applied the formula of area. In one right angle triangle, find out two different area. Then I found one of the part and then I reached on to the answer of finding out the length. So pattern here is still same, equating area to find length. But you just have to see the story of the problem is changing. The pattern is still the same. You need to identify that pattern from the problem and then reach on to the answer. Okay, that's why this would help you with your practice of equating such pattern. So let us now solve another problem where you have to equate area to find area. Okay, that's the pattern that we had been following. And based on that pattern, there is one more problem that appeared in CAT 2017. Okay, let's understand there's a theta problem. So type in the answer. There is no option for this. You have to find the answer and type the answer. Okay, so let's understand what is given. Let P be the interior point of a right angle isosceles triangle ABC with hypotenuse AB. If the perpendicular distance of P from each of AB, BC, CA is this 4 square root of 2 minus 1, then the area in square centimeter of triangle ABC is. Okay, so I need to find out area by equating certain areas. So let's see how will we do this. So first let me make a right angle triangle and understand as to what is being given in this problem. So this is a right angle triangle. It's an isosceles right angle triangle. Okay, what is the meaning of this? If this angle is 90, these two sides are equal. So these two angles will be equal. The remaining angle of 90 is being equally distributed. So this becomes 45. This becomes 45. If it's a 45, 45, 90 triangle, what do I know? The sides will be in the ratio of 1 is to 1 is to root 2. Okay, that is first thing I understand. With hypotenuse as AB. So this is AB, hypotenuse. So this becomes your point C. If the perpendicular distance of P from each of this side AB, BC and CA is 4 square root of 2 minus 1. So what do you mean by this? I take a point here. Perpendicular distance of this point from AC would be this. Perpendicular distance of this point from BC would be this. Right? And similarly, perpendicular distance of this point from AC would be this. That's what I make it here. And all these three are equal. So this is equal to this is equal to this. The measure of this is 4 into square root of 2 minus 1. Okay, that is being given to me here. So that's what I understand. Then what is the area of triangle ABC? So what is the easiest way to find out area of triangle ABC? If I know this, area of triangle ABC would be half into BC square, right? BC into AC, but BC is equals to AC because it's an isosceles triangle. Question is, how will I find this out now? Okay, this is where your thinking starts. This is where you have to think. So what do I know here? I know that something called as incircle. What is an incircle? It is a point of intersection of your angle bisectors. Angle bisectors intersect and then you draw incircle. Right? So that is all I know. But there is no angle bisector here. But there is, if I draw a circle inside this, see, understand. if I draw a circle inside this, which is say like this, that will be called as an incircle, yes. Okay, because it is inside the triangle and touching the three sides of the triangle. The three sides of the triangle are tangent to this circle. It's an incircle. So if that is an incircle, this will become an end radius. This will become an end radius. I can say this is r, right? Because perpendicular distance is nothing but there is an height, okay, which is again, as you can see, this becomes the radius of this circle. R is here, R is here, R is here. So now I have to think in something in terms of wind radius. Do I have something in terms of wind radius? Yes. I know something in terms of wind radius, that if this side is equals to A, okay, I don't know this. Let's say this is A. And if this side is again equal to A, because they both are equal, so I am saying both are A. So what will be the other side? The ratio of the side is 1 is to 1 is to root 2. Multiply this by A. So A is to A is to A root 2. So this side becomes your A root 2. Right? That is quite understandable. I have a formula which is for finding out the end radius. That is what we again study in the basics of geometry. Okay, which is what? End radius R is equals to sum of the other two sides minus the hypotenuse divided by 2. End radius in a right angle triangle is sum of the other two sides, which means A plus A, that becomes equal to 2A, minus the hypotenuse, which is A root 2, okay, divided by 2. That is a formula for end radius. So I find this out now. Okay, that end radius is equals to this. What is end radius? That is given to me already. What is this? 4 into square root of 2 minus 1. So just write it here. This is 4 into square root of 2 minus 1. The entire thing is equals to 2 into A minus of A square root of 2 divided by 2. Done. There is only one variable here, A. You can easily find the answer. So solve this. So I'll say let's take square root of 2 into A out from here. So what is remaining here is square root of 2 minus 1 divided by 2 is equals to the entire thing 4 into square root of 2 minus 1. This gets cancelled. This is square root of 2. This becomes square root of 2. So eventually I get the value of A is 4 into square root of 2. What is my answer for area of the triangle ABC? That is half into A square. Right? That's what I know. And A is my 4 into square root of 2. So 4 into square root of 2, the whole square will be what? 16 into 2. Right? That is A square. That is equal to half. So half gets cancelled. Answer is 16. And that is the answer that you have to type in to reach on the right answer to this. Okay, so all that we did here is applied the formula, which is area of the triangle half into base into height. Isosceles triangle half into A square. But you have to understand the perpendicular distance that is being given here is nothing but the end radius of a right angle triangle. Okay, you have to get that click. The moment you get that click, it's just about applying the formula and reaching on to the answer.